Hey everyone, and welcome. Today we're going to tackle something that seems super simple on the surface, but is actually incredibly powerful, the straight line. And it turns out there's more than one way to describe it mathematically. So let's open up our straight line toolbox and see what's inside. So just think about it for a second. A line, it goes on forever in both directions, right? It's infinite. So how in the world can you possibly capture all of that information in just one simple little equation? It seems kind of impossible. Well, here's the secret. There isn't just one magic equation. It's way better to think of it like a toolbox. You know, you wouldn't use a hammer to turn a screw. It's the same deal with lines. Depending on what little bits of information you already know, you're going to reach for a different tool to get the job done. But before we even crack open that toolbox, we have to talk about the single most important property of any straight line. It's kind of the secret ingredient that shows up in almost every single one of our tools. We're talking about its slope. So what is slope? Simply put, the slope, which by the way we almost always call m, is just a number. That's it. It tells you exactly how steep the line is. A really big number means you've got a steep climb, a small number is a nice gentle stroll, and a negative number means you're heading downhill. It's like the line's personality. All right, now that we've got a handle on slope, it is officially time to open up our toolbox. Let's pull out the first and probably the most famous tool of them all. Okay, picture this scenario. You know exactly how steep your line is. You've got the slope. And you also know the precise spot where it crosses that main vertical, or y-axis. What's the perfect tool for that job? It's this one, the elegant, the famous slope-intercept form. I guarantee you've seen this guy before, and there's a really good reason it's so popular. It's just the absolute fastest way to picture a line in your head or sketch it out. And here's why it's so awesome. That m is the slope we just talked about, the line's steepness. And c, that's the y-intercept. Think of it as the line's starting point. The exact spot on that vertical axis where it begins its journey. Okay, but let's be real, things aren't always that neat and tidy. What if you know the slope, but you have no idea where the y-intercept is? Instead, all you know is one single random point that the line happens to pass through. For that, we're going to need a different tool. And here it is, the point-slope form. Now, I know it might look a little more complicated at first, but trust me, it's perfectly designed for exactly this kind of situation. So, how does this one work? Well, just like before, m is our slope. Easy enough. That new part, the x1, y1, that just stands for the coordinates of that one single point that you know. You just plug in the numbers you have, and boom, the line is perfectly defined. Now let's kick it up a notch. What happens when things get even trickier? Let's say you don't know the slope at all. All you've got are 2 points just kind of floating in space, and you know there's a straight line that connects them. Now what do? For this, we pull out the 2-point form, and this is where things get really clever. Take a close look at that fraction in the middle there. See that? It's actually calculating the slope for you, right inside the equation. So yeah, all you need are the coordinates of your 2 points. You just label one of them x1, y1, and the other one x2, y2, plug them into the formula, and it does all the hard work. No need to figure out the slope ahead of time. It's pretty slick. Okay, let's look at another common scenario. Let's say you don't know any random points, but you know something very, very specific. The exact spots where your line smacks into both the horizontal x-axis and the vertical y-axis. For this special case, we have this beautifully simple tool, the intercept form. I mean, just look at that symmetry. It's so clean and direct, it feels like it was literally designed just for this one job. Here, A stands for the x-intercept. That's where the line cuts the horizontal axis. And B is that y-intercept we've seen before. If you happen to know those two values, this is, without a doubt, the fastest tool in the box. All right, time for a more specialized tool. This is one you might not use every day, but when you need it, man, it's a lifesaver. What if the only thing you know about a line is its shortest possible distance from the origin, the very center of your graph? This is where the normal form comes in. And yeah, you can see it's using some trigonometry, cosine and sine, but don't let that scare you off. They are the perfect functions for describing something when all you have is its distance and angle from a central point. In this equation, p is that direct, straight line distance from the center to your line, and alpha is just the angle that little perpendicular line makes with the positive x-axis. It's a very geometric way to think about a line. So, We've got all these specialized tools, right? Each one perfect for a specific job. But what if you just need a Swiss Army knife? One equation that can adapt to any situation and represent any line out there? Well, you're in luck. There is one. This is the general form, and its real power isn't in how it looks, but in what it can do. You can take any of the other equations we've talked about and, with a little algebra, rearrange it into this format. It's like the universal translator for lines. Once a line is in this form, you can instantly extract its deepest secrets from those numbers a, b, and c. As you can see, the slope is always just negative a over b, and the intercepts are just a quick calculation away. This is the bedrock that connects everything else. Whew! Okay, that was a lot of tools. So to wrap this all up, let's put everything onto one super handy reference slide. Think of this as your final cheat sheet. Now, this isn't just a list of formulas. This is a decision-making guide. The next time you're facing a problem with a straight line, all you have to do is ask yourself, what information do I have? This chart will point you to the most efficient tool for that specific job. And that's the real power of this whole toolbox idea, having the perfect instrument for any problem you face. So a straight line isn't just one equation. It's a whole collection of powerful, flexible tools. And these tools, they're the language of physics, of computer graphics, of engineering, of economics. We haven't just handed you some formulas. We've given you a lens to see the hidden mathematical structure all around you. So the only question left is, now that you have the toolbox, what are you going to build with it?